This is Elijah Johnson, and I'm going to be doing Lab 3 for Physics 2. I used an online simulator to model how a capacitor charges in a basic DC circuit, so let's get into it. The purpose of this lab was to see how voltage and current change over time when a capacitor charges in a unit. So I used the FET circuit construction kit to simulate the circuit, which made it easy to track how things like current and voltage behave over time. So here's what I use to understand the circuit. So first there's Ohm's law, which is voltage is equal to current times resistance. Then there was the charging equation for capacitors. So when the capacitor changes, the voltage across it goes up over time and the current goes down. The time it takes for this to happen depends on the resistor and capacitor, and it's called the time constant, which equals resistance times capacitance. In my circuit, the resistor was 1,000 ohms, the capacitor was 100 microfarads, and the time constant came out to zero point 0.1 seconds. So, in the circuit I built, it had a battery, a resistor, a capacitor, and a switch. When I closed the switch, current flowed and the capacitor started charging. At the beginning, the current was about 10 milliamps, and the voltage across the capacitor was 0. As time went on, the voltage increased and the current dropped. After zero point 0.1 seconds, which is one time constant, the voltage was around 6.3 volts. The capacitor was almost fully charged after half a second. So here's two graphs to show what happens. So on the left, you can see the voltage rising. It starts at 0 and gets closer to 10 volts over time. On the right, the current drops from 10 milliamps to almost nothing. This matches what the equation said would happen, so the simulation was working like an ideal circuit. So let's talk about real world versus ideal considerations. So in real life, things wouldn't be as perfect. For example, a real ammeter has some resistance that was slightly messed with the current in the circuit. In the simulator, the ammeter is ideal. It doesn't affect anything. Also, if I tried to charge a capacitor using a real battery and no resistor, the math would say it charges instantly, but that doesn't happen in real life. The circuit would spike and maybe damage the circuit, and real components always have some resistance to slow things down. Oops. Okay, so yeah, in conclusion, this lab helped me understand how capacitors charge over time and how current and voltage change. It also made me think about how real circuits aren't perfect like in the simulation. Anyway, thank you for watching. Wait.